Hi, this is Brian Gracely, and in this video we're going to talk about PaaS, or Platform as a Service, P-A-A-S. Now, if we think back to what we talked about in a previous video, where we tried to relate the various types of layers of computing with the sort of the layers of cloud computing, we got to this analogy where we sort of said you had hardware, right, which relates to infrastructure, which is what we talked about, infrastructure as a service, okay? And then we had the operating system, the OS, which really relates to what we're going to talk about now, which is PaaS, or Platform as a Service. And then on top of both of these, we have applications, right? In the case of a computing device, server, it's an application. In this other model, we tend to call that software as a service, or SaaS, okay? But we're primarily going to focus on this layer right here, Platform as a Service. So let's think about what the OS does in a pure basic compute environment and what a PaaS does, or a Platform as a Service, tries to do in order to allow this to work for cloud computing environments, okay? So what it's really doing is a couple of different things. And just to throw out a couple of names so that you can put Platform as a Service into context, there are a lot of different companies and open source projects and activities that are what people will call Platform as a Service today. So I'm just going to throw out a couple of names. This isn't an all-inclusive list, but this will help you when you're reading things in the news and the media and so forth. So some of the more popular Platform as a Service are more well-known. Google has one called Google App Engine, GAE. Microsoft has one called Azure, or Azure. VMware has one called Cloud Foundry. Salesforce.com has something called Heroku. Red Hat has one called OpenShift. What are some of the other ones? There's one called CloudBees. There are a whole bunch of EngineYard makes one. A bunch of different Platform as a Service, and really the distinguishing characteristic is some of it's architectural, and we'll talk about what it means, the architecture of a Platform as a Service environment. Some of it has to do with whether they are closed environments or open source environments. Some of it has to do with whether they run in public clouds only, or they will be supported in private clouds. And then also the last characteristic tends to be which programming languages or which programming frameworks do they support. Some of them are specific to certain frameworks, so for example, Microsoft.NET or Java, or some of them support multiple languages. So they'll support Java and .NET and Scala and Perl and Ruby and others. And so developers will make their decisions based on, you know, what works best for them. Do they write to a specific language or a framework? Are they looking for an environment that lets them support multiple languages and multiple frameworks? Are they looking for something that is public only, something that's open source? Lots of different variations in there. So let's talk about the basic of what a Platform as a Service is really doing, right? So again, we're going to keep coming back to these same sort of stack drawings, but we're going to have infrastructure, right? We're going to have infrastructure that delivers us servers, storage, network, and the underlying, you know, security and other functional things. We're not really talking about this here, but it's there, it doesn't go away. And now with Platform as a Service, and I'll draw it a little bit bigger so we can include a number of things, within PaaS, we're going to be talking about, you know, the way that it interacts with a number of things. The first thing is it's got to have ways to dynamically interact with the infrastructure, be able to request that virtual machine if we're dealing with an environment that serves up virtual machines, or just bare metal servers and storage and the underlying network resources. So it's got to be able to talk to the infrastructure, and it's going to do that through APIs. Okay, so one of the really important things as we start to move up the stack for cloud computing is more and more of this type of communication, you know, between the layers, between different devices, this type of communication is going to be done through what are called APIs, or Application Programmer Interfaces. This is in essence a programmable way for one area of a stack, one layer of communication, one layer of an application to talk down to different devices in a way that doesn't have to involve individual people, individual humans. It's not a scripting language, but it's a set of programmatic calls between computing devices that allow them to to interact sort of natively. Okay, so the first thing a PaaS has to be able to do is deal with the infrastructure. Just like an operating system has to be able to deal with CPU and memory and I/O, PaaS has to be able to deal with the underlying infrastructure. The next thing a PaaS has to be able to do is it has to be able to say, well, what's sort of the framework for the application? So up here somewhere, I've got applications that are going to reside in this stack, okay? And those applications want to be able to speak or be developed and speak their native languages. So .NET might be one of them for Windows, Microsoft environments. Java is a very popular one. Ruby might be one. Perl or Python might be one. Python. So there's a lot of different sort of frameworks, and again, these are programming languages and programming models that the PaaS has to be able to deal with. And again, these are sort of frameworks, and then to a certain extent, there's sort of this programmatic way that these are going to interact with each other. Okay, and again, we're talking about a sort of a different layer in the stack. We're talking about very programmatic types of things. We're talking sort of programmer language here as opposed to infrastructure language. We're not talking about networks and ports and disks and RAID. We're talking about programming languages and APIs and so forth. And then there's the things that the PaaS has to be able to do that's sort of its guts, its middleware, if you will. That being able to deal with, how do I make sure that multiple customers can carve off resources? So this might be customer A and customer B and customer C, but also that different environments can go and get resources. So a set of resources that are going to be CPU resources, or they're going to be certain types of processes that they can run for a period of time, development, application processes, they can run for a period of time and then stop them and start them and spin up more processes as needed depending on the load of the application. So a web process, an Apache process, some other type of set of processes. So there's both a containerization function for a certain process or for a certain customer that has to happen within a PaaS environment. And then there's also this sort of process interaction between this process and that process to make sure that if this one behaves badly or this one behaves the way it's supposed to, that the errors and the fallback and the resetting and all those sort of things that have to happen for an application that an operating system would traditionally have done in a traditional computing environment, all those things can be done in my PaaS environment, right? So the really important thing again as we talk about PaaS is there's a bunch of characteristics that we're thinking about. First and foremost, we're probably talking about new applications. Most people aren't going to take a legacy application that was written 10 years ago and try and wedge it into a PaaS environment. We're really talking about new applications. We tend to talk about web scale applications, web applications, things for mobile devices tend to be a really good candidate for PaaS. Anything that's probably going to be new, right? Great candidate for a PaaS environment. The next thing we tend to look at for PaaS environments, so we're going to probably have new applications. That tends to be the starting point. I'm going to write to a new application. I'm going to figure out what sort of language or framework that I want to write to. So this is sort of the language of the developers, okay? It's Java, it's Ruby, it's whatever it is, okay? Scala, whatever the latest language that they want to write in, okay? They want to know, is this open source or is this closed source? And there's benefits to both, right? Some application PaaS frameworks are open source, things like Cloud Foundry. Others are more closed in what they do, but ultimately they both have ways to have these APIs be able to access what happens within the PaaS. So in some cases, organizations want to strictly work with open source. Others are okay with more closed environments that have more direct support models. But as long as they can get to the application framework the way they want to, they can manipulate it and change it the way they want to, that tends to be that next big critical environment, big thing. The third thing is, can I run this in public or private environments? And some of these PaaS will run in only public. Others have been architected so that they can eventually run in private, even if they don't do it today. But really the big thing that people tend to look for when they look at PaaS platforms